I'm Mr. Leung. I am your new earth science teacher, and we are about to enter the wonderful world of minerals. First thing we have to do is we are looking at a part of science which has to do with observations, which are different from inferences. An observation is something that you can directly sense with your five senses. Which would include vision, hearing, touch, taste, and smell. When we're looking at rocks and minerals, the one that we're not going to be using is taste, because that would be in bad taste. Seriously, one of the issues would be there are some minerals that we do have that could be poisonous. So we are not going to be taste testing. Vision, things you can see with vision. Color, texture, and something we call luster. Luster is basically how does the mineral reflect light. We can cut it down to two possible types of luster. This whiteboard, this pen, the glass window, the curtains in the back of the room. I'll let you turn around and look. All of those would be considered one type of luster, which we're going to call non-metallic. The other type of luster we have would be something we call metallic. This would be metallic. That is not. The door handle. Desk legs, the faucet. I think most of you guys have a pretty good idea of what is metallic. Some things could be confusing, like a mirror, because really the top surface of the mirror is glass, which is non-metallic, but the back of it's silver, which is metallic. But really that's our other possible choice. Hearing. If you're hearing rocks, you might have a problem. And hearing rocks fall on the floor isn't going to help us identify it. But it still is something you can observe. Touch. When it comes to minerals and rocks, again look at the texture. Indirectly, we'll be looking at how hard they are. And finally, kind of related to density, which we'll do when I actually can get to the class, we're going to be looking at something called heft, which is the relative density of the mineral. Finally, there is smell. Some minerals do smell, usually bad. So I'm not going to go into any detail because you'll know it when you smell it. So, there's one other thing we have to look at. And that is inference. What's an inference? I can infer that roughly between 14 to 16 years ago, you were born. I obviously haven't met you. How am I doing that? I'm doing that because of past experience and indirect observation. If you happen to have been a 7-year-old child prodigy and you were sitting in the class, since I'm not able to observe you at the moment, you would throw off my inference. But I'm assuming most of you here are teenagers, and you are in 9th or 10th grade. And by the inference of my past knowledge of the fact that you were 9th or 10th grade, you are most likely between 14 to 16 years old. Now, I've observed most teenagers are, if they're in 9th or 10th grade, between 14 and 16 years old. So that's the indirect observation, because I've never seen you in particular grow up for 14 to 16 years. But because I know of the general pattern, I can infer that. So what I'm going to do is I'm going to have your substitute hand out this worksheet, and you're going to work on this for about 5 or 10 minutes. Okay, ready?
No.
And we're back. To your first rock video. Okay, it's not truly going to be rocks. Rocks are made of minerals. So we're actually going to have to look at this the same way that you had to look at the body. If you really think about your body, it started off as cells. Certain cells organize, become organs, and then all the organs together become your body. Minerals and rocks are in that same basic idea. Minerals are made of elements. Certain elements combine and they can make minerals. A combination of minerals becomes rocks. So they step themselves together. Since minerals are the building block of rock, we got to look at minerals first. So we're going to start with minerals. Okay, to identify minerals one from another, we actually will be performing a series of tests. The tests are okay, hardness. Hardness is the resistance of a mineral to scratching. Conversely, it also could be the ability of a mineral to scratch another mineral. It is based off of its chemical makeup, something we'll talk about later. But because each mineral has a unique chemical composition and crystal structure, which is how those elements go together, they all have unique hardnesses. Okay, for the purposes of this class, we will be comparing our hardness to glass. They are actually glass plates. Those plates, for safety reasons, must always be placed against a hard surface. So when they show you the scratch test on this video, you have to remember glass plates, not the windows in the room, on the table, flat, then you can scratch. Okay, the streak test. You're actually using a piece of unglazed porcelain, which is actually pretty hard, almost 6.5. So it has the ability to powder a large number of minerals. So what you actually see on a streak plate is powdered mineral. There's some advantages to this. It's always fresh mineral. So any weathering or aging of that mineral surface is taken out of the equation. And the other part would be some minerals can be polished, and there's actual natural processes that do that, which makes the color look different. Streak, always going to look the same. Again, for safety reasons, though not as delicate as the glass, these streak plates should also always be placed on a hard surface, not in your hand. They are not M&Ms. This mineral that you're seeing right here, which is in the cabinet at the back by the windows, is an example that shows cleavage. This happens to be a sample of calcite. This mineral here, also in the cabinet on the top shelf, is gypsum, and that also shows cleavage. These three samples have what we call fracture. Notice how it's not as neat and organized as the cleavage. This one has a particular type of fracture called conchoidal, which is similar to the type of fracture you see when you break glass.
Fabulous.
Okay, so I got to make some lesson plans to give to Mr. Ed.